Hello, this is Jonathan Ventura, and I am pleased to present to you our work on P1AC, revisiting absolute pose from a single affine correspondence. Our work is on image-based localization, where we assume that we have a set of reference images with known camera poses and a model of the scene. Our task is to determine the rotation and translation of a query image. The most widely known solver for this problem is called P3P, or perspective 3-point. Given at least 3 2D observations of known 3D points in the scene, we can estimate the pose of the query image. This is a thoroughly studied problem with a long history, and P3P solvers are currently used in many computer vision applications. In our work, we were interested to explore how affine correspondences could be used to improve image-based localization. An affine correspondence, or AC, relates the local image neighborhoods of corresponding points in a reference image and the query image by a 2x2 affine transformation matrix. ACs can be obtained in various ways, such as frame-to-frame tracking, affine shape adaptation, and deep learning. Recent work has developed the theory of two-view and multi-view geometry based on affine correspondences. It has been shown that the AC is a first-order approximation of the homography induced by the plane tangent to the surface at the 3D point. Additionally, an AC provides 3 constraints on the fundamental or essential matrix, whereas a point correspondence, or PC, only provides 1 constraint. In general, the extra constraints derived from the AC allow for the creation of minimal solvers, which use fewer correspondences than solvers using PCs, which speeds up robust estimation, especially when we have a high outlier ratio. While recent work has mainly focused on relative pose estimation from ACs, we revisit the topic of absolute pose estimation from a single AC, which we dub the perspective 1 affine correspondence, or P1AC problem. The inputs to the problem are a single observation of a 3D point in the query image, an affine correspondence to a reference image, and the surface normal at the 3D point. In our work, we derive novel constraints on absolute pose from an affine correspondence based on differential analysis of the transformation from the reference image to the query image. Based on these constraints, we developed the first general solver for absolute pose from a single AC. In synthetic data tests, we established the numerical stability of our solver and its performance under various types of noise. In our real data tests, we validate the use of ACs for large-scale image-based localization and show that our P1AC solution achieves higher accuracy and recall than P3P and other baseline solutions on standard benchmark datasets. To derive the P1AC constraints, we assume that the surface is locally planar and model the transformation from the reference image to the query image using homography. We analytically derive the Jacobian of this transformation, which is equal to the 2x2 affine matrix from the AC. This provides 4 constraints on the pose of the camera, which when combined with 2 constraints from the observation of the 3D point, gives 6 constraints in total on the 6th-off camera pose. In our paper, we show how to efficiently solve this system of equations. We compared our P1AC solution to P3P when used in a robust estimation loop on synthetic data. When using LO ransack, our P1AC solver was faster than P3P across all outlier ratios tested. For our real data test, we used 2 benchmark datasets. The first is the Cambridge Landmarks dataset, which contains smartphone images of several outdoor scenes. The second is the Aachen day-night dataset, which includes smartphone images taken both at daytime and night, and thus provides a greater challenge for image-based localization. On the Cambridge Landmarks dataset, P1AC had the lowest median error and highest recall among all methods we tested. On Aachen day-night, we saw an especially large boost in recall from P1AC on the night dataset. In terms of timings, P1AC was slower than P3P on Cambridge Landmarks, but faster on the more challenging day-night dataset, which had higher outlier ratios. To summarize, we derived novel constraints and a minimal solver for absolute pose from a single affine correspondence, and we achieved lower error and higher recall on benchmark datasets compared to P3P and other baseline methods. Future improvements could come from AC refinement techniques and using camera pose voting instead of ransack. Our code is available online. Thank you for listening.